xi plus this error. After y, I would do that. This is a general model for regression. Each one of these observed y's that you have over here will be equal to a hat plus b hat. The first one runs x1 plus error 1. The next one would be a hat plus b hat x2 plus error 2. And this one will be a hat plus b hat x3 plus error 3. And so on. The last one would be a hat plus b hat xn plus error n. Right? Everybody follow that line? No questions? Good. Now, the method that we use, and there are a number of different alternative methods to use, but the one that's commonly used for economics is one where you want to get the line which will minimize these squared errors. In other words, we square that error, and we want to find the a hat and the b hat, which will minimize the sum of those square errors. Okay. Well, the ordinary squares thing, we form this function, d, is equal to error 1 squared, error 2 squared, error 3 squared, plus error n squared. And we want to minimize that d. We want to find the alpha hat, the beta hat, which will make that d be as low as possible. Now, before we actually do that, we have some assumptions about this model. And these are the assumptions. First of all, xi is exogenous. And then that means that it's given. It's not a random variable, but this is specified. Nice big term to use in the vocabulary, exogenous. Very impressive when you're out on a date someplace. Or exogenous. Now, the other is EI is a random variable. RV means random variable. And it has a normal distribution. We write that like this. Distribute like normal. With mu equals 0. And variance, some variance. We don't know what the variance is. We call it sigma squared. How many people have not had it in their statistics? You never had statistics before? You're going to be lost.
Yeah. Good luck on the final.
What?
Good luck on the final.
Awesome.
So mu equals 0. Normal is 0. Mean is 0. But the variance is something unknown. You have to know statistics to do anything in economics. So you can't do, I think we even require 2 statistics courses.
Yeah.
So that means the distribution of epsilon I is like that, symmetrical, green equals 0, and this distance from here to here is
600 bands
one standard deviation.
for people who haven't had that at all. What are you doing either? Is it econometrics? Yes or no?
Now, because this is a random variable, and y is a random variable, because it's a function of a random variable. Any function of a random variable is a random variable. Now, since y is a random variable, we do what we always do with random variables when we have them. We got to compute the mean and variance. We have yi equals a hat plus b hat x I plus epsilon I. So the first thing we want to do is get the mean of y. So mu of yi is the expected value a hat plus b hat x I plus epsilon
We
I.
didn't do that last semester.
You have to get the expected value of that. Now, a hat, b hat, and xi are all constants. So the expected value of a hat plus the expected value b hat xi plus the expected value epsilon. But since these are constants, there's just a hat plus b hat xi, and the expected value of ei is this mean, which is equal to 0. So the mean of yi is this. Now we want to get the variance of y. The variance of yi is equal to the variance of a hat plus b hat xi plus epsilon I. You see how we do that in statistics? Well, whenever we want to get a mean of something, we put into the formula expression for it. When we get the variance of it, we put in the formula for the expression of the expanded. Right? And then we can break this variance up like this. It's equal to the variance of a hat plus the variance of b hat xi plus the variance of epsilon I. Now, a hat and b hat are constants. They don't vary.
So that's 0.
So they're equal to 0. This is equal to 0. xi is exogenous. That doesn't vary either. That's equal to 0. So the only thing we have is the variance of ei. But we know what the variance of ei is by assumption of sigma squared. So the variance of yi is sigma squared. Variance.
Okay.
Right? We save that for later. We'll come back to that. But that's the basic assumptions around this model for linear regression. That the error term is normal, it has mean 0, and it has a variance sigma squared. Now, sometimes people will run these regressions, and that these assumptions don't hold up. And consequently, the regression again is not valid. That's what happens when you go to these meetings, the American Economic Association. People pick at the equation to see if they can find something wrong with it. If they do, it shoots down the paper. So when you're doing research like this, you've got to make sure that all these assumptions are valid. Otherwise, you get picked apart. Okay? Good.
That also makes sense.
Huh?
Also makes sense.
Yes, makes sense.
Makes sense?
Yes, that makes sense.
It's got to make sense, of course. Now, we're going to rewrite this. The function in terms of the epsilon I. First of all, epsilon I is equal to, here's epsilon I. If we bring these two on the other side, we're getting it's equal to yi minus a hat minus b hat. We get that from the things over to the side of equal signs, then change. Then epsilon I squared is equal to this square. Now another way of writing this is using the statistical summation sign. Summation I equals 1 to epsilon I.
Okay.
What's on the bottom? I plus 1?
I equals 1.
Or I equals 1?
That's not routine.
I equals 1 to n. The i's are in the top. First xi, x1, x2, x3, and that's right? It's a subscript. Now we can write d like this. D then is equal to the summation I equals 1 up to n. Yi minus a hat minus b hat xi squared. We're going to go with the board here. Start using this. Unfortunately, the Fed, when they ask me for people, I showed you that. Did I show you the beginning of the last one?
I don't know.
Women or something like that, you said?
They want the people who know econometrics, they want the people who know computers, they want the people who have good math background, quantitative background. But they also want women. I sent all the male candidates, they didn't want them, they only take women.
That's discrimination.
Now what we have to do is minimize this d with respect to a hat and b. How do we do that?
Minimize B?
We want to minimize this d with respect to a hat and b hat. How do we do that? How do you minimize any function with respect to anything? This is high school math.
Take them out of the equation?
You differentiate.
Is it differentiate?
You differentiate. You have to use differential calculus.
Derivatives.
It's taught in all high schools these days. So, no excuse.
When was the
for not
last
knowing
time
that.
you were in high school, honestly? Come on.
What? You didn't graduate high school?
It's a negative 10.
Yeah,
So we're going to do that. We're going to differentiate this. First with respect to a hat, and then with respect to b. Okay. So we're going to get the partial differential of d with respect to a hat will be equal to the summation I equals 1 up to n. And we're going to differentiate inside it here, underneath the summation. So when we differentiate, the first thing do, what do? We'll remember.
Take down the exponent.
Take down the exponent and put it over here.
Put it
right?
over there, yep.
Good. You take down the exponent 2, yi minus a hat minus b hat xi What do we put up here? After we take it down, what do we put up there?
-1.
Minus 1. So 2 minus 1 is what? What?
Really?
We don't have to put the 1 up there.
There's some high school math.
Are you confused?
Don't you have to differentiate?
Sorry?
Don't you have to differentiate the inside first?
We're getting to it.
Oh, okay.
But first,
What is that? What is that?
now we have to differentiate the inside. We're differentiating with respect to A hat. So what will we get when we differentiate with respect to A hat? Minus 1. Right. Times minus 1. Right. Now, we can rewrite this as summation minus 2 y1 y minus A hat
They should
B
be
hat
more open
equals
this.
x hat. Now, we're dealing with a surface with a sort of like this. We want to get to the bottom of it, and there'll be a sheet out there. We have x, y,
Two-dimensional equation. That's what he's trying to do.
that's equal to d.
Yeah, but you gotta do a better job. That's not, doesn't look 3D, it's 4D.
Well, he's trying to make a two-dimensional equation.
So what we get at the bottom,
Cheshire cat.
the partial slope of this will be 0, will be the horizontal line. And when we differentiate, what we're getting is the slope of a tangent line. And the slope of that tangent line at the bottom has to be horizontal, be minimal. It's anywhere along the sides of this thing, it won't be 0. It'll have a numerical value, plus or minus numerical value. But right at the bottom, if we're minimizing, it'll have to be 0. Right? So this thing will have to equal 0. This is the slope of the tangent. That has to equal 0. Now, I'm going to take this and divide it both sides by minus 2. Now, what happens over here? Minus 2 over minus 2.
Cancel out. Wait.
1, right?
Yeah, 1.
What about 0 over minus 2?
0.
0. So when we do that, we get the following. We get the summation I equals 1 up to n yi minus a hat minus b hat x hat equals 0.
Huh.
That's the condition for minimizing.
Okay.
One condition. All right, now, we'll put the summation sign in here. So this is the summation I equals 1 to n of yi minus the summation I equals 1 to n of a minus the summation of b hat of xi n equals 0. We can move the summation into like that. Now let me just remind you what these things mean.
Doesn't the B hat goes before the summation sign?
The summation I equals 1 to n of yi equals y1 plus y2 plus y3 plus y7.
Yeah.
That's what that means, all right? Now the next one, summation of alpha a hat. That's A hat plus A hat plus A hat plus A hat, n of them. We add up A hat n times. That's what that means. Right? And that, what does that give us? N times A hat.
Okay.
That's what that means. And the summation I equals 1 to n of b hat xi equals. We can take the b hat out of the summation.
Yeah, that's what I was saying.
Times x1 plus x2 plus x3 plus x of n.
What, in the sigma A hat, it was equals A hat plus A hat.
N of them.
It has one.
There's n of them. There's no subscript on this. There's n of them. Right? That's what that means. That's the definition of that. And this is the definition of this. Okay? So now we can rewrite this as a summation I equals 1 to n of yi is equal to n a hat plus b hat times the summation all of this combines this. So just bring the negative back on the other side of the equal sign. Good. Now we're going to do a very simple mathematical trick. Kind of things that mathematics love to do. We're going to divide both sides of the equation by n. So I'm going to divide this side of the equation by n. And I'm going to divide this by the equation by n. So n over here is a hat, because n over n is 1. Okay. Plus b hat times the summation
X.
When I divide both sides by n, I'll get the summation of yi over n. That's going to be equal. N is here, n's cancel out, a hat, b hat, summation xi. What you do one side of the equation, you do the other. Now, what do we call this? When we add up n numbers and divide by n.
Average.
The average. We usually write that as y bar. Y bar is equal to a hat plus b hat. And what do we call this?
X bar.
X bar.
X bar. Good. So, the first condition to minimize z is that y bar is equal to a hat plus b hat.
Okay.
That's a condition. One condition.
This would lead.
Conditions to minimize D. You'll see how all of this relates to computers very shortly.
Yes.
So I just want to give you first a little bit of theory, and then we'll get on to computers. The first condition, y bar will have to equal a hat plus b hat.
So see how you find your computer address.
Now we'll get the second condition. You get the second condition, you're going to have to go back to D, and differentiate it with respect to b hat.
Using the final internet service IP address. No desktop connection.
giving you guys $1 million education. You're only able to make $1 million with this kind of knowledge. So we have D, partial of D with respect to B. Equals summation I equals 1 over n. And we do the same thing. We start with the 2 and bring it down. 2 times yi minus a hat minus b hat xi like that. Now we have to differentiate inside the parentheses. But this time we're differentiating with respect to b hat. What happens when we differentiate it with respect to b hat? What do we get?
Negative x side.
A negative xi. And we're going to do the same thing. We have to set this to 0 if we want to get the bottom of the surface. So when we put this together, we'll have summation I equals 1 up to n. Take the minus sign of a minus 2 xi times yi minus a hat minus b hat xi. And that equals 0. And once again, we'll divide both sides of this equation by minus 2. We'll divide this by minus 2. Divide this by minus 2. And what we get is the summation I equals 1 to n xi times yi minus a hat minus b xi. And that's what it's. And now we'll just multiply the xi across here. We'll get the summation I equals 1 to n xi times yi xi times a hat and xi times b hat xi. And then equals 0. And now we'll bring the summation inside the parentheses. I equals 1 up to n xi yi minus summation I equals 1 to n a hat xi minus summation I equals 1 n b hat xi squared. And then all have to be And now we'll bring the negatives over into the side. We get the summation. Xi yi is equal to a hat and the summation of xi plus b hat times the summation of xi squared. So that's condition 2. Condition 2 is this, the summation of xi yi